Okay, I think we're on. I think I'm recording, although you never know. Okay.
I don't think you are recording because normally there's like a little green, like blinking bar right there.
Well, it's not there. It's a new program, so it's on the other screen that I see. So
Cool.
we'll see if it works. There's your attendance. I'm going to try to screen through 2 chapters today, and talk about the final project. We do not have class Wednesday because of the charrette. You should have all gotten the notices on that. Everybody have any questions on that? There's a lecture this afternoon at 5, I think in the middle room. Miss Minute will explain the details. And then everybody needs to participate in some form or fashion. I think you can work on teams, but then when you turn in whatever it is you create, like if you're in 2 of my classes or if you're on a team, everyone turn in a PDF of the drawing in each class on each assignment, okay? Because you'll be an assignment grade on each class. So does that make sense?
So you want a different design for
No,
class?
it's just one design. Like you're in several classes.
I'm in all 3.
So you can turn in the same thing, just turn it in 3 times so that I'll grade it 3 times.
Sounds good.
So, okay. And mainly I'm looking for participation. I'm not looking for, there'll be I guess a panel that's going to decide who wins the prize, if there is a prize. I'm not sure how it's working this time. I've been out of the loop.
The prize is going to be you're awesome.
You're awesome, yeah. And I know they're presenting at the Art Walk on April 4th. So anyway, that's that. Now I'm just going to, I was a little disappointed we had an exam right before spring break, right? Last year. I'm not sure what went wrong, other than, make sure you're reading the chapters. And I give you, don't think you can get everything you need from me, because you can't. And there's just too much information. And you should, when I give you terms to review, you should probably try to find those terms ahead of time, because usually that's a word from each question that's possible. And you don't get all the questions because there's a question bank. But that's how I do the reviews. Like I go through every question and I figure out what it's asking you, what term or whatever, and I say, you better know that. So try to prepare a little bit better for that. There is opportunities for extra credit, of course, in this class with the details, but then you haven't seen this yet because I delayed. There's an announcement on Canvas. Next week, we're having Skills USA competition. Y'all know what that is? Well, Del Mar hosts it every year. And it's basically all the high schools in the area, or it's the state competition. And so they have drafting competitions, and they come here and they draft stuff. And then architects and architecture students are asked to judge it. And Mr. Flynn and Mr. Klepak are in charge of it, and it'll be Thursday night, March 27th, so a week from this Thursday at the American Bank Center, and there'll be an announcement on Canvas. And so what I'm doing for my students, since the more judges, the better it is, because it goes faster, because it's like the American Bank Center full of drawings that has to be judged. Just so there's a lot of drawings. But and it starts at like 5:30, and it usually takes till about 10 o'clock at night. So the more people, the less time it'll take. But if you go and you sign in and you help with that, you can, if you're in absence trouble, because remember, if you have 3 absences, your grade has dropped a letter. You can wipe out an absence or 2. I can't remember what I said. Or if you don't have absentee trouble, you can add 10 points extra credit to a test. So it's a community service and improve your grade. All in one swoop. Anyway, let's get started. I'm going to get through these chapters and talk to you about the final project. So we're into concrete construction now. These 2 chapters, or maybe one's roofing, I can't remember. Like I said, it's been 2 weeks. And these slides are on the Canvas website, so you can read them thoroughly. But as noted, concrete has been around forever, since volcanoes started erupting, basically. Modern concrete was invented more in the 1800s with the Portland cement by Joseph Aspdin. That's just some schematic drawings of concrete, how the concrete and steel work together. Concrete is very strong in compression, and steel is very strong in tension. And when you get into structures later on, when you start studying structures, this is a concrete beam, and this is the steel reinforcing in that beam that I'm pointing to right there. And so you can see where the concrete would tend to bend. You got more steel at the top because that steel is strong in tension, which pulls. And then down here where the concrete's going to bow down or bow down, you got more steel. So that's kind of how they work together. And then there's more the concrete at the top is obviously strong in compression. So it's a very good combination when you have reinforcing steel in concrete. So there's, just like everything else, there's specific ingredients that are used. You've got the coarse aggregate or the gravel, you've got Portland cement and water. And those have to be done in a specific ratio. And this just talks about how the Portland cement is made. We'll study that. More information on that, the clinker. Air and training cement is where you add bubbles to the concrete. It makes it a lighter concrete. It's obviously less strong that way, but there's all different things you can do to concrete to give it different qualities. And these slides talk about that, depending on what you want. It improves the workability. You know, concrete is obviously a very heavy, thick substance. If you've ever seen people pouring concrete and those poor guys out there in their rubber boots moving in around, that's one job I would never, ever want. But it's a very, you know, it has to be able to be workable, but it also, you know, the lighter and easier it is to move around, the less strong it is. So there's a fine balance between, you know, workability and strength that it needs. And these are different types of cement that are used. Of course, you would specify this in your specifications according to the ASTM, what the engineer requires. You know, sometimes you might need to build on it really soon, so you'd want a type 3 high early strength cement where it will get its strength early on and you don't waste time in your building of your project. Sometimes you might need some other properties that you would add stuff to. One thing concrete does do, it emits a lot of carbon dioxide gases. So that's one bad thing about it, but I think they're improving those, the way it's made nowadays. Plus, if you use recycled stuff, it helps with that. Just another pollution diagram. Won't get too much into that. Aggregates are the rocks. You know, you can see rocks in concrete usually if you dig through it. They have to be clean, and you usually want them to be of uniform size and shape, depending on what you need. And they have to be small enough to fall down between the rebars in your structure. So your rebars and your whatever aggregate size your rebar, I think, has to be 1.5 times the distance between them has to be far enough apart for the aggregate to fall down in between. There's a lot of rebar, you can see. And like I just said, it has to fall between, be able to, you know, come down and fall between all of those different things.
How do they get the rebar bend like that? That's like crazy.
I think that's a sculpture. This is more, that's just for, that's not a real thing. I think this is this is a floor or a parking garage or a roof or something that obviously needs to have a lot of strength in it, all that rebar. But you can get it to bend, but not, I've never seen a situation like that. So. That's an exaggeration. Let's see. talks about the aggregate size distribution, the grading of the aggregate. The lower percentage of a void space between particles results in stronger concrete. So, you know, it's getting that balance between the aggregate and the concrete and just the right mix and size so it's the strongest and workable. Lightweight aggregates are used to make lighter weight concrete. You'll use a lightweight concrete, for instance, on a roof, roof decking material, or even maybe a floor decking material. You know, like here, this might be lightweight concrete underneath this, but it's on a steel floor, you know, a ribbed steel floor. And then I know it's used a lot on roofs as well. So, and you would use different aggregate, lighter weight aggregates like the volcanic aggregates and the shale to get that lightweight. It's not as strong, but you don't need it to be as strong. Then water is an essential ingredient. Must be free of contaminants. Generally, any water you can drink is good enough. You can't just suck water out of the ocean or a pond. It has to be clean water to make sure it mixes well and has all the right chemical reactions. That's just more supplementary materials that you could put in your concrete for different reasons. Study that. Other add mixtures that you would add as air and training, water reducing. You may not want a lot of water in your concrete for whatever reason, so you would add that material. Cure accelerating or making it cure faster, shrinkage reducing, corrosion inhibiting, freeze protecting. If you're pouring concrete, you know, in the north, you might need to have freeze protection. You can also put color in it, which is becoming more and more popular to make just like in grocery stores, they have, you know, just the bare concrete floors or warehouse stores, and they usually have some color added to that, so you don't have to add tile or anything on top of it.
The hallways over here have that, right? Like
Yeah, those look like they have, it's like a polished concrete. High early strength for tall buildings. Anybody know what building this is? Well, it says right there, but it's the Burj Dubai. I used to show a series of films on that and how they made it. It's very interesting, but we've kind of run out of time to do that kind of stuff. You could probably Google it if you're interested. It talks about how all of the building technology has come to be able to make a structure like this. What, you know, elevators and concrete and all that stuff. It's a pretty interesting series. Maybe if we have a sick day, I'll show it or something. So, let's see. So workability is important when you're placing the concrete, but you need to maintain your structural properties, and it just lists the important properties that you need in concrete. Normal concrete is up to 6,000 psi compressive strength, but you can get higher strength concrete up to 20,000 for whatever, you know, reason you might need it. You can see this is a very thin concrete floor on this, probably a apartment complex or something. So that would have, you know, probably some additives in it to be able to do that thin and very strong floor. This just talks about the water-cement ratio, which is important. Increases this, less water increases the concrete strength and durability, decreases the workability, and increases the cost. So you have to get that balance. And the engineers will be out on site testing all this when you're pouring your concrete, and if they don't like what they see, they'll send it back. So the concrete is usually mixed, or it's made in a plant and then put in the trucks, which we've all seen on the roads, and taken to the construction site. And there's a very specific time period. It can only be mixed for so long and in transit so long. So you have to have your concrete plants, you know, within a certain distance for it to work good. And the slump test is very important. This is one they do on site, and it's kind of obvious what it is. They'll take a concrete from each truck that comes. They test each batch, and they'll put it in this bucket And then they'll turn the bucket upside down and they'll see how far it slumps. And a concrete with too low of a slump, probably, it's too stiff and it'll be too hard to place. And if it just falls all over the ground, it's obviously too soupy and not going to be strong enough. So they say here the range is usually 3 to 5 inches, and you can see that that concrete in that picture has slumped down, looks like about 3 inches, which is probably okay. So that's an easy on-site test to do. They also do strength tests. They take core samples of the concrete. Sometimes they might leave them on the site in the same conditions that the actual concrete is being cured at. Sometimes they'll take it to a lab, or they might do both, and then they'll test it at certain points in time to see, make sure it's up to snuff. And if it's not, they can make them tear it out and do it over again, because you don't want your building to fail. Placing concrete, you want to pour your concrete as close to the finished place as possible. You don't want to, like this crane is probably going to pour a roof deck or some sort. So it's lifting it up to the roof and it's going to pour, from about that high. You don't dump it from way on high, because then it will splat and all the aggregates will separate out and it won't. You want to pour it close to where you are and then move it around so that everything stays pretty much cohesive. You can see here it's coming down the pump, and he's just holding it there and dumping it in there, and then the finished guys come around. So they're not just dumping it from 50 feet above, because that just doesn't work. Here's just more pictures of them placing it. They're rodding or tamping and screeding. Of course, the consolidation is very important with the stiff concrete, but you don't want to over-consolidate it. It has to all just be just right. So, curing concrete can take, it's usually an average about 28 days, I think, is when they say you can start doing whatever you want on top of it. And that's just different times after with the different additives. Formwork is probably the most expensive part, or at least as expensive as the concrete itself, because basically you have to build this super strong structure that will hold that wet, sloppy concrete until it dries, and then you got to take it down. So if you can get reusable formwork, that helps a little bit in your cost, but it's also, the formwork has a lot to do with the way the concrete looks when you take it off, because if it's nasty formwork, it's going to be nasty looking concrete. If you want to have wood grains showing on your concrete, then you can make it look woody. I think there's pictures of that in a minute. But that's probably it's the most time consuming and the most expensive part of the concrete work itself. Reinforcing is the steel. And this just talks about the tensile strength, as I was telling you about earlier in concrete. How that steel and concrete work together. Steel reinforcing bars. And the reason that, these are rough like that is because that bonds to the concrete better when there's more notches and edges. Gives it more space to bond. When we talk about reinforcing bars, we say like a number 4 bar is always the total width of an eighth. Like a number 4 is 4/8, so that'd be ½ inch. A number 8 is 8/8, so that'd be a 1 inch diameter steel bar. There's 5/8, there's 3/8, etc. So if you see that number, you know that that's a 3 or 4 of 8 of the diameter. You can use, obviously, higher strength bars to lessen the need for the bars, and so you don't have the congestion problem, and your aggregates can get down easier. Welded wire reinforcing is used a lot on the slabs or driveways, stuff like that, and that just acts like little rebars that are like a welded wire mat, and that's the designations for those. Again, you need that in your concrete for your tensile strength, because even if it's a driveway, you're going to have a car or something, that car weighs down on it, it's going to want to bend it. So that steel will, even though there's ground below it, will help keep it from cracking. lot of times the reinforcing is prefabricated and brought to the site. Like this would probably be circular column reinforcing, and then they'll stand it up and attach it. Here's a giant, looks like giant column or something they're putting together, and they're going to turn vertical. And you can see this, they've poured the bottom part, now they're going to continue up with this column here. It's a lot of steel, but still, you know, the steel and the concrete are a good match, especially in high-rise skyscrapers. That's a good diagram of the strengths of concrete and steel. Lines of compression when the concrete will tend to squeeze together, lines of stress when it will tend to pull apart, and you can see you got your supports here, your support here, so the concrete will tend to, you know, bow down there, and so you need that steel in there to keep it from pulling apart. There's some more columns, and the things that go around these are the vertical reinforcing bars, but then you got the ties or the spirals that go around to keep it all together and not, you know, just spreading out. You can also use fibrous reinforcing or these things in different situations that you might call for that, glass fiber reinforcing. Pre-stressing. We went on our field trip. Did he talk about that? Where the cables are stretched through the slab, and we didn't see that? Okay. Well, typically that's getting to be more and more how it's done, post-stressing and pre-stressing of the concrete. Where you can use less steel with these cables, and you pour the concrete and you pull them real tight. And then once the concrete's cured, you chop them off, and everything just kind of goes like that, and it's compressed all together. That way it's a much stronger foundation, and you can use less steel. That's a diagram of that.
What kind of machine or tool do they use to?
Probably just some sort of like winch crank thing. And then, but once the concrete's dried, they can just cut it off at the face of the concrete. I think there's a picture of it in a minute, and it won't go anywhere.
And it just compresses the concrete more?
Yeah, it makes it all kind of just still. Yeah. Those are the cables stretched out, getting ready to. There's pre-tensioning and post-tensioning, which are kind of the same but different. Pre-tensioning, obviously the steel strands are tensioned before the concrete is cast, so they're pulled tight. Post-tensioning, the steel strands are tensioned after it has been cast. So it's just, I think pre-tensioning is done more in precast concrete, and the post-tensioning is done more on an on-site application. And we got a movie. Let's see. I'm going to pause this. So that's kind of even though he's selling his coupler, it's a good little overall video on concrete. So then we're moving into chapter 14, which is site cast concrete framing systems. Let's see here. And these, again, are some more details that you could look at for extra credit. Typical, a lot of what we have around here is slab on grade, and that's what this detail is showing, where you don't have any hollowness below the slab. You have your earth, and then you have some sort of crushed aggregate for drainage. Then you have probably a vapor barrier. Then you have your concrete, and then that line right there is the welded wire mesh. And then you can also see these little dots might be the welded wire mesh coming towards you. So that's how that's shown, and then you got your finished floor on top of that. And here's a structural concrete floor, which is kind of what I was talking about earlier. You would have your metal decking or floor decking, corrugated floor decking. Then you lay a lightweight concrete in that with some wire mesh in there. All that would probably sit on some sort of joist, either wood joist or open web steel joist. So those are typical concrete flooring details. And this is, of course, an exterior concrete block wall. And these are concrete block walls as well. So you got to prepare your site. That's probably one of the most important things, is getting the site prepared. Typically, especially for a commercial building, you'll need to probably scrape down 2 or 3 feet to get to some stable soil. You'll bring back in some fill, which will be specified by the engineer, back up to the level of where you want your concrete to start. Because you can't just go out and pour it on whatever's there, because you don't know what's underneath there. There might be, sinkholes, or you just never know. So once you get your soil prepared, then you put this is the rocks I was talking about, like a drainage area. That would be this part right here, all these little rocks. And then over that they put a waterproofing membrane to keep the water from coming back up into the concrete. Here's a driveway situation where they have rebars instead of the welded wire mesh. I guess it depends on what, but they do have some aggregate below it, which is important. They prepared the subsurface. And they have wooden forms that will hold it in place, that will be removed. You also have isolation and expansion joints, just like in the other materials that we've talked about. You need a joint between an old and a new, or 2 different pores, and this is that material right there. And then you would have a joint sealant that you would come in and squirt in there to keep gunk from going down in there. But that allows movement in your structure, and so that things just don't crush against each other. Here's another picture of the vapor barrier, or the moisture retarder. And you can see it has to be pretty solid, and wherever there's penetrations, they have to make sure that they are sealed off as well. Right there you can see you've got some sort of drainage coming up through the concrete. So there's your vapor, and then they've taped down this other stuff to make sure that there's not just a gaping hole there. Here's another picture of welded wire fabric, and then they have these little things which are called chairs, and that's what I call them. I'm not sure if that's what they call them here, but that holds your, because you obviously want this to be in the middle of your concrete. If your concrete's 4 inches thick, you want that at about 2 inches. So you have to have these little chairs to make sure this stuff doesn't just rest on the bottom and sink down. Here's a picture of them pouring again. This is from a pump, obviously coming down, and this is a truck. They're putting it into the wheelbarrow, and they're going to take it to where it needs to be. Again, as close to the final position as possible. So again, it's just telling you here that the steel has to be put in the middle of the concrete. Sometimes guys will go reach in there and lift it up after it's poured. Then they're screeding it right here. They're striking it off and making it semi-level. They're talking about a bulge is maintained in the front of the screed to fill in any holes as they pull it down. After they do that, then they'll float it, and that's a bull float is what he's using. It's a very long float, so you can stand off the concrete and obviously do that, and that consolidates it, gives it a smoother surface. And this guy's using a Darby float, where you can do that, where you can reach it by hand along the edges specifically. And then he's finishing the concrete. You don't want to leave it like this, because that's just breakage waiting to happen. So if you finish it with your different kinds of tools, edgers or groovers, then a smooth corner is less likely to chip off and break when things hit it. There's also power floaters, which is what this guy's doing. We use that on you can stand on concrete pretty soon afterward, obviously, as you can tell here. but it's still not cured, but it can certainly hold the weight of a man up. Troweling is even for a smoother finish. If you want like a really slick, like that out there is pretty slick. But if you don't want a slick finish, then you can do the broom finish, obviously, which is a lot of sidewalks have that and stuff, so that you don't slip on them. So then after you get all that done, you got to let it cure, and sometimes you might need to cover it up if you're in to either protect it from rain or to keep the moisture in if it's a very hot, dry climate, because you don't want it to cure too fast. You don't want the water to come out too fast. And depending on your climate or your weather situation, you might have to add some sort of curing compound. Also, you need to put some joints in it because you don't want these kind of cracks happening. So you want controlled joints. So those don't go all the way through. They just go, maybe a quarter inch or something, so that it's kind of like a controlled crack. See, they should have continued that one on because it did it anyway. Concrete has a mind of its own. And it talks about the rule of thumb. Joints should be spaced 24 to 30 times the depth of the slab. So for a 4-inch slab, joints should be spaced no more than 8 to 10 feet apart. So, and here's obviously this column and this column foundation were poured before this, and so that has that expansion joint material around it because that concrete was poured up next to that. And it looks like they had joints here and there, but they didn't have one there, and they should have. So casting a concrete wall, that's pretty tricky. A lot of form work involved. We talked about this on the field trip, I remember, because there was a deep foundation wall for the man cave in that house if you were there. So this is kind of how they had to do that. They would pour a footing, and there would be the wall reinforcing would then be placed in the wall, which is these things with the orange tabs sticking up out of it. Then there's these ties that are going to hold the two sides of the wall together after the other side is put up. They're talking here about a shear wall, the steel that's needed for that. Shear wall is when things slip past each other, like an earthquake. It's not a bending force, it's a sliding force. So it's very important in wind and earthquake zones. These are heavily reinforced shear walls. Here you can see, again, you got the formwork, the wood for the walls, you got your concrete coming up, and then you got these ties, which are going to hold the two pieces of wood together and keep them straight without buckling out while the wet concrete's in there. And then they'll snip them off once they take the formwork off. That's kind of what they look like. And you can see here how it breaks off in the wall. And you could see some of those marks on the walls that we saw out on the field trip.
Do they use anything to break them off, or they just snap them off?
I think they pretty much snap off, but I guess they could use pliers or something if they needed to. You can cover them. If you don't cover them, then they might get some rust and stuff, so you can put some putty and stuff in there or some, grout to cover it up. So it takes a very strong formwork to hold, obviously, a concrete wall because it's very heavy, wet concrete. And it's talking about the different formwork here. You've got bracing and the form ties and the wailers, which are these horizontal reinforcing. And you got your formwork panels, and this is what the panels are what make a difference in how the concrete looks, because whatever's on that panel will be on your concrete. So if you want a smooth panel, you obviously wouldn't use wood. You'd use maybe some sort of plastic smooth stuff, but in this case, wood is probably okay. Here they have a wall form that will actually slide up the wall so they can reuse it, which will save them money. So they'll pour like 6 feet and then they'll inch it up, pour another 6 feet and inch it up. Because that's obviously going to be a tall wall that they can use that formwork over and over again.
Do they have to let it cure totally before they can move it up?
Probably not the whole 28 days, but I'm not sure. That'd be up to the engineers to how long until they can move it up. It's a good question.
Well, wouldn't you
Oop, wrong way.
kind of want the concrete to bond with each other?
Well, the steel is what's going to bond it, because you can see the steel sticking up, like that guy was talking about in the movie, and then they have to have some sort of overlap or coupler when they add another piece of steel. But what they'll probably do is, once this slides up, then they'll overlap the steel or put the coupler on there and add more steel so that this connection will be in the middle of the wall. It won't be at a joint of the concrete. I keep going the wrong way. Okay. Or am I going the wrong way? Okay. We haven't. Okay. So, there's a lot of formwork on that one. That's going to be a freestanding wall, so it's going to take a lot of stuff. It'll look very nice and clean once it's all done. Beginning in there is messy. There's another self-climbing formwork. So they pour the concrete in the wall, and then they consolidate it. One thing they didn't talk about on the, which they do, is they have these vibrating hoses, like in slabs and in walls, where they'll stick it down in there and it'll kind of wiggle around, and that gets the concrete in between, settled, and between all of the different rebar. So they have to do that in walls too to make sure there's no holes or pockets, air gaps, because that'll totally destroy the wall. And once they do all that, then they strike off the top. And then after several days, the formwork may be stripped, but curing continues for at least a week on this situation. So you can see here what your concrete looks like. It looks like your formwork. And depending on where that's going to be, it might be okay. If it's not really going to be seen, if it's going to be covered up, you can use crappy stuff. If it's going to be seen, then you care about what it's going to look like. And the different patterns. You also can block out if you're going to have some ductwork or electrical running through these holes. You can block, or windows even in your foundation wall. Block that out. Now here's what the wood pattern. So they wanted obviously a wood-looking basement wall, and you could paint that, and that would look pretty cool, I think. But you got to make sure you have good, clean wood, and it's got a nice, it's not just scrap wood. Here they probably didn't vibrate it quite enough, because you can see it kind of messed up. It could have been, yeah. And depending on where that is, the engineer may say not do it over, or that probably if you're not going to be seeing that, that's probably not a big deal on that one. There's one coming up. I think that's a bad situation, because you can see all the exposed aggregate and the steel. That's just not going to work. They're going to have to probably cut this out and pour a new section there. Cutting concrete's not easy either. It's harder than pouring concrete. So you want to control your cracking, like we're talking about the joints. And this is a retaining wall, and you can see the moisture coming through the cracks in that retaining wall. Probably should have had more vertical joints in there. This is a new kind of, they're using it more and more. It's called ICF, which is styrofoam. It looks like styrofoam CMUs, but they're made of styrofoam. And so it's a very good insulator. And then they stack them all up, and then they pour concrete in it, and it makes it just an extremely strong and durable house form. It's good for, like, if you want to stay in your house during a hurricane, you do it this way. So the only issue is, obviously it's hard to remodel if you wanted to, but what they do with this another thing they do is they can groove this styrofoam to run the electrical wires. Now, plumbing you pretty much have to put within the concrete, but thin stuff, electrical wires and things that you're not ready to put in when you're pouring the concrete, they just groove out this styrofoam and lay it in there, and then it's all covered with sheetrock. Here's a tilt-up concrete panel. They pour it flat on the ground where it's easier to pour, less formwork obviously, and then they tilt it up. So that's warehouses do that a lot. Large buildings. So
You see a lot of that kind of work in Houston.
Mm-hmm. Exactly. So here they're talking about a column. First you got to pour the footing of the column, and you've got the reinforcing in there. Then you can have either a square pattern or vertical pattern or a circular pattern. And the outside of the columns actually look the same there, just the inside, the way the reinforcing bars are done is different. And that's, again, depends on, the engineer will specify what he wants for whatever reason. And you got the ties around the columns, which I was talking about earlier, to keep them from buckling. Here's some more reinforcing patterns. How it might, this is cutting through the column and looking down. Here's the real reinforcing. And you can see in this, I don't think they're using the coupler device in here, but these are kind of bent in so that then they can overlap and add another layer of rebar once this gets poured. You can see clearly there how they're going to, these are prefabricated somewhere and then they're brought to the site and then they're going to lap them together after they're up. Then you got the column forms that they're fixing to put that around that one, and they can reuse those if they keep them in good shape, or slide them up the column as they go. Here they're pouring the concrete. They filled it into this bucket, and then they take it with a crane, and they want to get it down. They don't want to. There's probably a tube going down at the bottom, and then they'll shorten it up so they don't just dump it 10 feet down. There's the finished column, ready for a new layer on top of it. Then they got the one-way floor and roof framing systems. So this is just different ways to, boy, it's a lot of information, but y'all got a week to absorb it. So, different ways to have your slabs integrated with your concrete. Girders are the deeper beams, so this is a girder, and then the beams are shallower, and you've got the columns, obviously, and then you got the slab on top of that. So a one-way slab, the system of beams, the slab is reinforced in one direction only, meaning it's going this way, depending on the arrangement of the beams and columns. And you can see, well, the beams are going that way, and then your slab reinforcing is going from beam to beam. So that's a one-way slab. A two-way, oh, I'm going too fast. Yeah, okay, so, and then a one-way rib joist slab has columns, beams, and then more like ribs between these joists. So you can span greater, but it's a little bit more complicated. Here's a formwork for that, sort of a prefabricated formwork, joist pans. Here's a wide module concrete joist system. So depending on your needs is what, you would choose. And these are talking about primarily like parking garages and things like that. Two-way floor and roof systems. Remember we saw that thin floor before, there's another thin floor. This is what you would use in this situation where you don't want joist sticking down or ribs. You want a flat finish, so you use a two-way system. And when you do that, your columns generally need to be as square as possible. Close, a one-way slab, they can be further apart in one direction, but in a two-way, you want them to be pretty balanced and square. So here you can see a picture of that, and you can also have these like mushroom capitals. And here you can see that the reinforcing in the slab is going in both directions, and then you've got probably a little heavier dose of the reinforcing between your columns where there's going to be more of a load, acting like a sort of a flat beam. And here's a parking garage that uses that. Two-way flat plate. That's probably what was in that apartment complex we were just looking at. And they're going to use the tensioning, post-tensioning on that. That'll help increase the strength as well. And you can use less steel when you do that. So they'll pour the concrete with the steel in it, then they'll pull the steel real tight and let it go, and it's like contracts back up. You can see it sort of in progress there. So you see how, this is how nice a space that makes. And then that wouldn't be your ceiling, but you'd have plenty of room to run ducts or whatever, and then have a drop ceiling like this underneath it. The waffle slab, obviously, why it's called the waffle. And you could fill all this, add some strength there, but then you don't need concrete in all these holes. So there's, I think, use that in like garages and things. This is obviously has more rebar in it because this is where a lot of the structures coming together. Okay. Whew, I'm exhausted. So y'all need to continue studying those two chapters, and I don't really have any exercises on it. I want to talk about the final project now, which is due at the end of the semester. You may want to revise this a little bit because you'll see in a second. This is online, but I made you copies. This is where all your detail drawing will come in handy. Did someone leave? Okay. All right, so the final project for the semester consists of modeling a construction assembly in AutoCAD or by hand if you don't use AutoCAD yet. And it should be completed by each individual student. The assembly, meaning the type of wall, which I'll explain in a second, should be presented on a final presentation drawing, meaning a nice, neat drawing, drawn with care and concern, so not just scratched out on a piece of tissue. And then accompanied by a 2-page report, double-spaced, describing the construction assembly. So basically you're telling me in 2 pages all the ingredients of your wall and why they're there. The assembly may be of your choosing. For instance, light wood frame, like the walls we used at we saw at the field trip. It can be a metal frame wall section, a timber frame building, or heavy timber or concrete block, whatever you want, whatever we've kind of studied. You can look through the book and see what you like. So this project is worth a test grade. And so you would kind of look through the book, and I want you to choose what you're going to do within the next week, and then you'll turn in your assembly selection. Is there any questions on what I mean by assembly? That's why you just have to, instead of an exterior wall, you have to tell me what kind of wall. So this is an example of a wood frame construction wall, and I want the whole wall from foundation to roof, a whole wall section. So this, and I want it drawn to scale, and I want things labeled. This probably doesn't have enough labels on it, but it kind of shows you, what I'm looking for. Dimensions, if necessary. and labeling all of the different components of the wall. This is a metal frame building, which is probably beyond your scope, but I'm just showing you again that that's a wall section and what it looks like when you draw one and you label all the ingredients and you dimension it from foundation to roof. Oops, is that it? Okay. So if you look more at this, the third page of it, you see the grading scale. So this can give you an idea of what I'm looking for. You're going to present it to class. That's worth 15 points. And I don't really want you to just read your report. I'd like you to be able to talk about it. And if you want, it's hard sometimes in the past students have just, and it's fine to do them like on an 11 by 17 piece of paper, but if you're standing up here presenting that, you in the back row, you can't see it, right? So if you have time, you're not like working on it until the last minute, you can make a slide or something and we can put it up here and you can show it on the screen while you're talking about it. That might be a better presentation. But all of this, you're going to do that on the last day of our class. So the oral presentation is worth 15 points. The report, which is if it's 2 pages double spaced, that's 10 points because I want it 2 pages and I want it double spaced. I want you to describe each component of the wall. That's worth 20 points. And I will check for spelling and grammar. That's worth 10 points. Being an architect or anything in the construction industry, you're going to have to learn to write well. So that's, the point.
It's one of the requirements, I think, college
Yeah.
composition or something like that.
Yeah. And I think there's the writing center has helped. Like if you write a proof or whatever, they'll help you with that kind of stuff. So all of that, to that point, the report is worth 40 points. Then your drawing, I want it to be drawn to scale, meaning everything's relative. If you need to know how to use a scale, I'll show you. But in general, an architecture scale, this has 3 sides. So you can, like if you're if you're drawing it I would say probably they need to be drawn at least 1 inch equals a foot. So if you're doing that, you would find on here the 1 inch equals a foot, and say if you're drawing a concrete block wall that's 8 inches wide, then you can count on here and figure out how wide that would be 8 inches. And I can give you more help with that if you need it, if you don't know how to do that. So then of course, so is it drawn to scale? Is each component labeled? With arrows saying what they are. Is it neat and easy to read? And are the different components distinguishable? And by that, there's different hatching patterns. And like in this picture, you can see insulation. And then I can tell that this down here is concrete because it has the dots and stuff in it. This is the earth around. And then rocks would be the little. So I can tell the different parts of that wall just by looking at it. So the total wall section drawing points are 45, and all that added up together equals 100 points. On the next page is what you're going to turn into me next time we meet, which will be a week from today. You're going to tell me your name, what kind of wall you're going to do, and you're going to say, I so-and-so understand that this is the final project, blah, blah, blah. I've chosen to draw it in either AutoCAD or by hand on 11 by 17 with a 2-page double-spaced typed report describing the wall section materials used. This project is due on Wednesday, April 30th at the beginning of class. That's our final class day. And then you will also be presenting it that day. So, any questions on that? So you got more than a month to work on it. Oh, and there is, if you notice, I think on the syllabus, about 2 weeks before that, I'm not sure, I think I have it on Canvas, but I want a draft of your projects. I want to make sure you've been working on it. And you can ask me questions, of course, anytime up until anytime during the whole process. But I want to see either, your drawing sketch or, a rough draft of your report, something like that, proof that you're working on it. and not just waiting till April 29th. Okay. Okay, so is there any questions on all that information? It's a lot of stuff. I think next week we're going to do, so you can kind of read through and understand concrete. Next week we're going to talk about more concrete, and then the roofing chapter, and then we'll have a test the week after that, I believe is when it is. So, okay? Okay. All right, well, happy St. Patrick's Day.